Today we're going to talk about the algebraic properties of proofs. I know that this sounds like this is a horrible topic, but you've been doing all of these things since you were solving equations back in 6th or 7th grade. You just haven't called it these things, and you may not have used these terms back then. So let's look at some of these properties that you already know, but now we're going to formally define them. So this is something that you're going to want to have handy so that you can refer back to it when you're working on stuff. So the first one is called the addition property of equality. And what that is if we have A equals B, so two sides of the equation are equal, and we add C to both sides, the equation is still equal. So A plus C is equal to B plus C. And you do this all the time when you say, okay, I'm going to add 7 to both sides of the equation. You're doing the addition property of equality. You're adding something to both sides. Subtraction property of equality is the same thing. If we have A minus C, that is equal to B minus C. You're subtracting C from both sides. The multiplication property of equality, again, if A is equal to B, so for all of these we're assuming that A and B are equal, then A, let me use the same color, A times C is equal to B times C. So you're multiplying both sides by the same thing. And then the division property of equality is going to be dividing both sides by the same thing. So A divided by C is equal to B divided by C. So like when you're solving for x, then I say, okay, now we're going to divide both sides by 4. That is the division property of equality. Now the substitution property of equality, so if A equals B, that means anytime you see an A, you can substitute that for B. So anytime you see an A, you can substitute B for it. And that one is going to be useful later on. You may not have used that as much up until now. Maybe when you were solving equations in Algebra 1 by substitution, you use this, but you have not used this as much as the other ones. And then the last one is the distributive property. And we've done this too, where, all right, we're going to distribute A to both of these. So then we get A times B plus A times C, where both of those things are now multiplied by this A out in front. So this is the list of properties of equality that we're going to be using. And like I said, these are ones you have already been using. They just haven't had this formal name. So now some more vocabulary. We have the word proof. And what that is, it's a logical argument that shows that a statement is true. So a logical argument that shows a statement is true. You might be arguing with your friends, and they may say, your argument is illogical. That doesn't make sense. A proof, though, is based on logic. And the type of proof that we're going to use is called a two-column proof. This is just one of the ways you can organize your thinking when you are making a proof, or if you're trying to prove something. So the definition is having has numbered statements and corresponding reasons that show an argument in logical order. Remember the other day when we had those machines that where one thing led to another and that led to another? That's kind of like what this two-column proof is, where we have a statement and then that statement leads to another statement, and our thinking follows those statements. So this will make more sense as we see them, but basically we're going to have two columns and we're going to have a statement and then why is that statement true in the other column. All right, so example number 1, we have solve 2x plus 3 equals 9 minus x and write a reason for each step. So we're going to make a two-column proof here for this. So we're going to start off with 2x plus 3 equals 9 minus x. Okay. And then here's my column. I like to know whether, okay, so that's what we're given. I like to number it. Then this is given. We were given this from the original problem. Then the first thing I would do when I would solve this equation is I would subtract 3 from both sides. Minus 3, I'll use a different color to help. Minus 3, minus 3. So the result would go into my next line. I would have 2x equals 6 minus x. That's what you would get if you subtracted 3 from both sides. So since I subtracted 3 from both sides, that is the subtraction property of equality. And instead of writing property of equality the whole time, we're going to write POE. I'm sorry, that should be a 2 here. The next thing I would do is I would add x to both sides. When you do that, you get your third statement, 3x equals 6. And what did we do there? We added x to both sides, so that is the addition property of equality. And then the last thing we would do is divide both sides by 3. So the fourth thing would be x equals 2. And what we did there was the division POE. So we solved this equation, but what we did in the second column was write down the reasons that we were able to make those mathematical calculations. The ones that I wrote in this light blue, that's the work that was shown, and then the reason is written over here on the right side. So if you can solve this and then name what properties you used, you're off to a great start. Then we can start to work with formulating this in the correct way. So let's look at another one. And I'm going to make my column here. So we have this, and that's given to us. 3 times x minus 5 minus 2x equals 21 plus 10x. And that is given. So if I were solving this, what I would do is I would distribute first. And once you distribute that, you would get 3x minus 15 minus 2x equals 21 plus 10x. So what we did there was we used the distributive property of equality, POE. Now what I would do is I look at the left side and I see 3x minus 15 minus 2x. I would combine those. I would combine my like terms. So I would say, okay, 3x minus 2x is 1x. So my third step would be to write x minus 15 equals 21 plus 10x. And what we did there was combine like terms. So you can think about each one of these steps that we're writing out is the step that you would use to solve the equation. And then you're explaining that step on the right side. Okay, so now the next thing we would do is I would probably subtract x from both sides. And you could go in a different order. It doesn't matter. You'll get the same answer. So then my fourth statement, or my fourth step, would be negative 15 equals 21 plus 9x. And we subtracted x from both sides, so my reason would be subtraction POE, property of equality. Now, the next step would be to subtract 21 from both sides. Oops, I want to use the same. Oh, so I want to use blue, or my light blue. Because what I'm writing in light blue is the actual work being done, but that's not what you would write in the statement. You would write like your final answer after, or your final step after doing that step. So like statement number 5 would not be subtract 21 from both sides. Statement number 5 is going to be, what does this equation say after I subtract 21 from both sides? So after I do that, I get negative 36 equals 9x. And again, we used the subtraction POE. And then the last thing we would do is divide both sides by 9. So then step 6 would be negative 4 equals x. And what we did was we used the division POE. So I know that this seems like it's a little bit extra and a lot of work for solving the equations, but as you get good at explaining your steps, when we do things in a couple days, you will have this process down, and those things will be much easier because we're putting in the work right now to get good at this. Okay, so for example, this next one, I'm going to set it up, and then I'm going to ask you to try it. Pause the video, try it, and then after you've tried it or you get stuck, then unpause the video, and I'll walk through this one as well. But I really want you to try this on your own first. So the first step is given. Okay, so pause it, try this on your own. When you're done, unpause it. If you get stuck, unpause it, and you can watch how I go through this, and hopefully that will make sense. Okay, so the first thing I would do is I would add 4x to both sides. So then my next statement would be 8x plus 13 equals 21. And what we did here is we did the addition property of equality, because we added 4x to both sides. Then to solve this, we would subtract 13 from both sides. And that would give us 8x equals 8. And what we did here was the subtraction property of equality. And then we would divide by 8, and that would give us x equals 1. And what we did here was the division property of equality. So I hope seeing this for a third time is now making you feel a little bit comfortable with explaining your steps. You know, like I said, the stuff I have written in light blue is our work that we're doing, and then we just have to describe what we did. All right, so we have a couple more definitions to talk about. The reflexive property of equality just means that something is equal to itself. Think about a reflection. When you see your reflection in the mirror, you are seeing you. So for any number, we have the reflexive property. It's just A equals A. It means the same thing. For any segment, the segment length is equal to itself. And then for any angle measure, the measure of the angle is also equal to itself. So again, this may seem super obvious, and it may actually confuse you. Like, why are we talking about this if it should be obvious that a number is equal to itself, or a segment length is equal to its own segment length? But these are just tools that we're putting in our toolbox to use later. The transitive property of equality is one that is used frequently, and it can be a little bit confusing to read. It says for any real numbers a, b, and c, if a equals b and b equals c, then a is equal to c. And you're thinking, that's a lot of a's and that's a lot of c's going on. And it is, so let's break it down. So A is equal to B, and B is equal to C. Well, it's kind of cutting out that middleman. And say, oh, then A must be equal to C because they're both equal to B. If I have a brother and I have a sister. Actually, I have two brothers and one sister. So if Andy is my brother and Andy is also Matt's brother, then me and Matt are brothers. We can just take out the middleman. We can take out the middleman Andy, because I'm Andy's brother and Matt is Andy's brother. Well, then I'm Matt's brother too. So the transitive property is pretty much taking out that middleman. And the same thing can be said for segment lengths. If we have segments A, B, C, D, and E, F, if AB is equal to CD and CD is equal to EF, well, CD is our middleman here. That means segment AB is also equal to segment EF. And the same thing is true with angles. If angle A is equal to angle B and angle B is equal to angle C, the measure of angle A is equal to the measure of angle C. Our middleman here is this angle B. In example 4, we're going to use these properties. So if R is equal to S and S is equal to 44, then R is also equal to 44. The middleman here is S. The reflexive property just says that something's equal to itself. So the measure of angle N is equal to the measure of angle N. the addition POE. So if RS is equal to TV, then that means if I have RS plus XY, that's the same thing as TV plus XY. Because these two things are equal, and I'm adding the same thing to both sides. So that is the addition property of equality. And the last one, the substitution one. So if the measure of angle 1 is 20 degrees, then the measure of angle 1 plus the measure of angle 2, well, if angle 1 equals 20 degrees, we can substitute that in. So then this is just going to be 20 plus the measure of angle 2. We're not solving anything right now. I'm just asking you to make that substitution. Right, so I know that this was a lot of information here. So we're going to take some time. We're going to process it. We're going to practice it. Please, if you have any questions, reach out and ask me, and I will help you. But other than that, I hope that you are able to get part of this done, and with more practice, you're going to get better at it. So I will see you later. Have a great day.